All right. Hello, everyone, and welcome to The Current, the North Central Region's, the North Central Region Regional Water, the North Central Regional Water Network's Speed Networking webinar series. This webinar series is going to be focusing on drainage water recycling. So we're going to be featuring three presentations that talk about research on conservation drainage and drainage water recycling. For those of you who might not be familiar with the North Central Region Water Network, we are a 12-state interdisciplinary group. We are extension-led, and we are dedicated to ensuring safe and sufficient water quality and quantity across the North Central region and beyond. We've been doing this webinar series, The Current, for the past decade. So we have over 10 years worth of webinars available to you on our media archive, which can be found on our website. You can see it there, northcentralwater.org. We'll post the recording and slides to this presentation on northcentralwater.org. And you can also go to our media archive and view all of the webinars from the past 10 years. Each month, we feature a different water-related topic and bring you 2 to 3 presentations on that water-related topic. And today we're going to be focusing on drainage water recycling. A couple administrative items for you before we get started. We will have a Q&A session. We have 3 speakers lined up for you today, and we will have a Q&A session following all 3 of the speakers. So please put your questions for our speakers in the Q&A panel. You can find that at the bottom of your screen. Please note that it's different than the chat feature. You can use the chat feature to let me know if you're having any technical difficulties. We'll also use the chat to share some links to some relevant research and programs for you to be aware of. You can also use the chat to introduce yourself to other individuals on the call. But make sure that if you have questions for our speakers, you put them in the Q&A to ensure we see them during the Q&A portion of the call. Another feature of the Q&A is the upvote. So we will take those questions that are most upvoted first. So if you see a question that you also have, make sure to give it a little thumbs up. That'll move it to the top of our list and ensure we get it answered during the session today. Lastly, if you're having any technical issues, you can let us know in the chat and we'll try to address those. If you are having any audio issues, you can use a phone-in option that can be accessed by clicking the up arrow on the mute icon and then clicking switch to audio, phone audio. All right, so I mentioned we have 3 great presenters. I'm excited to feature Chris Hay, owner and principal with Hay Water Solutions, Kelly Nelson out of the University of Missouri. Both of them are going to be sharing some research on drainage water recycling in particular. And then we're going to turn it over to Ehsan Ganj, who is a member of our leadership team on the North Central Region Water Network. He's also a member of the Conservation Drainage Network. So he's going to be talking a little bit about that network and the resources and programs available through that, ways to engage if you are interested in learning more about not only drainage water recycling, but all conservation drainage. All right, so let's kick it off to Chris Hay. Chris Hay is, I mentioned, with Hay Water Solutions, but he brings over 30 years of experience, most recently with the Iowa Soybean Association. So really excited to have Chris here with us to share a little bit about some of his recent work with drainage water recycling. I'll stop there and hand it off to you.
All right. Okay, well, good afternoon. And yeah, I'm excited to share a little bit about the work that we've been doing on drainage water recycling in Iowa, and want to recognize my collaborator. So Dr. Matt Helmers and his Ag Water Management Group at Iowa State University. They do the heavy lifting and on actually monitoring the sites, and then I get to help play around with the data. So I think when we talk about drainage water recycling, a little level set here, just for folks that may not be as familiar with it. I think the name's fairly descriptive of the general concept that we're taking subsurface drainage water, potentially supplemented with other water sources. We're capturing that, storing it in a reservoir, and then recycling that back onto cropland as supplemental irrigation. But then in practice, that can look several different ways that we can do that. And so this figure is kind of nice to show some of the different options that are available with drainage water recycling systems. So, we can look at different irrigation systems. So on the left-hand side, we've got sub-irrigation, where we're actually putting water back in through the drainage system itself. And then we use control structures and weirs to raise the water table up to or just below the crop root zone. And so the crops can access the water that way. On the right would be a more traditional irrigation system, a center pivot system there, but really we can use any type of irrigation system depending on what best suits the site that we're actually designing for. We've also got options then on storage. So on the left there would be, on a flatter topography site, we're going to have to do more excavation where we're excavating down and then building up a levee and creating storage that way. On the right, if we've got some topography that we can take advantage of, then we may be able to just create an embankment dam across a waterway or another draw where we can capture water and store it that way with a little less excavation. And then, we may be able to take advantage of some gravity flow in some situations like the outlet on the right, but in general, there's going to be pumping involved somewhere in the system. This shows capturing drainage and then recycling it back onto the same field, but that we don't necessarily have to do that either. We can, capture water from upstream fields to irrigate onto downstream fields. And again, that could be multiple fields or it could be single fields. So a number of different options, again, depending on what best suits each individual site. And then really what we're trying to do is optimize water management. And so, I think the challenge we always face with water management and agriculture is that unfortunately we never seem to get rain with the ideal timing or in the ideal amounts. And so we end up with situations where we have excess water. In the Midwest, that's typically in the spring, either before planting or early crop development stages. And then periods where we're water short, where we could use some more water for optimum production. And so again, typically in the summer, then we'll have some periods often where we're water short and could use more water. And so, if we look at the current trends in precipitation and then projected trends, both of these situations are expected to get worse. So more rain in the spring, meaning more runoff, more nutrient loss, and then more frequent and more extended droughts negatively impacting crop yield. So again, we're already seeing some of these trends, and these trends are expected to continue. And so going to make water management and drainage water recycling even more important. So really what the goal we're trying to do then with these drainage water recycling systems then is really trying to create multiple win-win situations. So I'd already mentioned dealing both with excess and deficit water conditions, but then we're positively impacting crop yield, but then we're also providing positive benefits for downstream water quality. And so by recycling those water and nutrients that otherwise be released downstream, again, we have a positive impact on water quality. Many of our nutrient reduction practices tend to target either nitrogen or phosphorus. This is one where we can have positive benefits for both of those. And so that's another benefit with drainage water recycling. In addition to water quality, we can also impact water quantity. And that water quantity can be kind of at the individual drainage scale, so benefiting the drainage system itself by adding some capacity that way, and then also at least at the local scale, some downstream water quantity benefits. And then if we do this at a large enough scale where we're building enough of these systems, that scale can expand further downstream by building again storage onto the landscape with these systems. And then finally, depending on how we design and manage the system, we can also have some complementary benefits. And so that could be wildlife habitat there on the left or energy production. So that could be floating solar panels shown there on the right or potentially even some small scale hydropower. So again, other benefits that we can build into the system depending on how we design and manage those systems. So with that little bit of background then on drainage water recycling, what I'm going to talk about then for the rest of my time then is a little bit about what we've seen so far for crop yield benefit in Iowa, and then also water quality benefits, and then talk a little bit about some of the big questions and next steps to continue to advance this practice. So again, starting with crop yield, we're lucky to have a site that was put in back in 2015. And so this was a family farming operation that I think in the times of $7, $8 corn, they had some money to spend. And so they actually, the impetus behind this site was they needed an outlet for this field for some of the drainage they wanted to put in on that field. And so they built the reservoir as a place to actually outlet that drainage. So it's about 20 acres of this field that they drain and then outlets into this reservoir. They're nearby a creek, and so they had the idea, well, as long as we're building the storage, we ought to put it to use. And so put in the center pivot to try and irrigate with. And so they also now got a permit to be able to pump water from the stream. That stream is largely derived from drainage upstream. So, it's both recycling their local drainage, but then also recycling some of their drainage that's occurring upstream that they pump into that pond. They're irrigating about 60 acres of that. It's about 120-acre field. So it gives us a nice control and treatment. So the area to the north of that is all part of the same field, same management, pretty much the same soils. And so again, a nice comparison between just rainfield yields versus what we get with the supplemental irrigation from the drainage water recycling. And so if we look at impacts then on, this is corn yield in bushels per acre. And so again, 2016, the first year that they started irrigating up through 2023. And we see that in every year that they irrigated, there was a yield benefit from that irrigation, as we would expect. In 2018, they didn't actually apply any irrigation. It was wet enough that they didn't need to. And we can see that the yields were essentially the same there. So again, another kind of indication that we've got a good control treatment comparison there. 2020, just you'll note there's no data there. That was the year the derecho came through, and so it knocked down the pivot and damaged the crop. It was unfortunate because that was our one soybean year. So we're still waiting for some good soybean data, but we've got several years then of corn data to look at. So if we focus in on what those yield increases are from the irrigation. One of the things you can see is, and what we kind of expect to see in these systems is, in 2017, huge increase, basically doubled their production, so 119 bushel per acre yield increase. And so that was a wet enough spring that they captured some irrigation water, but then dried up in the summer, and so a real big impact from having that supplementary irrigation to make up some of that water deficit. Then again, 2018, wet enough that they didn't irrigate, so yields were basically the same. But then in the other years, kind of a more modest benefit in that kind of that 20 to 30 bushel per acre range, with then an overall average of 34 bushels per acre of corn yield increase. So pretty significant and useful yield increase from that supplemental irrigation. So then if we turn to what we've seen so far for water quality, we've got a couple other sites that have come online then that give us a couple other sites to use to monitor. And so we're monitoring both the inflows and outflows of these, as well as what's coming in for nitrogen and phosphorus. So the first one's in Lake City, northwest Iowa. And so this is capturing drainage from upstream drainage district, about 1,400 acres, comes under a culvert under the road into a waterway. And so this one, we were able to build an embankment across that waterway, create storage that way. And we use that then to irrigate about 53 acres on that side hill. And then the second one is one near Dayton, kind of north central Iowa. And so this one, kind of the opposite situation. It's relatively flat field. And so they had to excavate, build up a levee to create this storage. This is one where they actually had to take some land out of production there in the corner of that field. But it was a kind of a low spot in the field that was often wet, and so they were often delayed or weren't able to plant that part of the field, and so they were willing to give up that portion of the field to hopefully have better production on the rest of the field. And so this one, we've got a center pivot that can do a full circle, and we get about 106 acres of that quarter section with the center pivot. And it's pulling from a county drainage main, so there's a sump there that tied into that drainage main and then pumps it up into the storage. So if we look at what the nitrogen impacts are. And so starting up on the top there, Lake City, again, that's the one where it's that upstream drainage district. All that water from that drainage district comes into the waterway and flows through that reservoir. And so we're looking at pounds of nitrogen on the x-axis and then the different flows of water and nitrogen on the y-axis. For reduction, then we're counting that as inflow minus outflow and seepage. We assume that all the nutrients in the irrigation then stay in the field. And so we can see that because all the water flows through that field or through that reservoir in Lake City, we get large removal of nitrogen if we look at the pounds on that x-axis and notice that the x-axis has changed with each panel. So 2022 is a little wetter year, so more water flowed through the system. So about 2,700 pounds of nitrogen that we removed. The percentage is a little less because, again, more water moved through the system. 2023, a little drier year, so we have an overall, greater percentage reduction, but the mass or the pounds of nitrogen is less just because there was less water and less nitrogen coming into the system. We look at Story City and Dayton. Those are ones, again, that we're pumping water up into the storage. And so, basically, there's generally no outflow from those systems. They pump in until it's full and then they stop pumping. And so high percent removal because everything that goes in pretty much goes back as irrigation with a little bit of seepage loss. But the load or the pounds of nitrogen is less because, again, we're only pumping what we can into the storage and then everything else bypasses. We looked then at phosphorus. Phosphorus is a little more complicated. And so I'm going to start with the bottom here. And so Story City and Dayton, again, we're pumping water into those to the extent that we can fill it up and then take it out through irrigation. And so generally higher phosphorus removal here in percent terms because, again, we put most of it back on the field as irrigation. We lose a little bit from seepage, but there's no outflow. But then again, what doesn't go in there bypasses, and so there's no treatment on that. Lake City, again, it's all flowing through the reservoir. And this one, we actually saw a pretty significant phosphorus loss in that first year. And we think part of that is that, again, we created this storage in that waterway, did some excavation work in that waterway. And so, probably fairly phosphorus rich soils that we disturbed. And so as that water moved through those newly disturbed soils, it was probably picking up some phosphorus that way. Then we also saw some scour in the outlet channel downstream, as well as, there's some cattle that have access to that waterway as well. And so, we think it's probably some of that leads to this overall phosphorus loss. On the second year, because of the amount of irrigation that we put on, moving a lot of that phosphorus, we actually then did see a reduction, even though there still were some increases in phosphorus concentrations as it moved through the reservoir and downstream. So I think, with a couple more years, we'll have a better idea of if that hypothesis is right about these newly disturbed sediments, and hopefully over time we'll see, some decrease in phosphorus losses and actually hopefully then some more phosphorus reductions. But again, that to be determined as we continue to monitor their system. So then, kind of looking at what the big questions are and next steps. And so, I think between the work we've done in Iowa and the work that Kelly and others have done in other states, we've got strong proof of concept that drainage water recycling positively increases crop yields. But then the big questions then are those yields large enough and frequent enough to justify the irrigation investment for the farmers, and then under what situations. And so, we need continued research with more sites and then some modeling to extend that in space and time to get a better handle on those questions. Then we also, I think, have proof of concept that we positively impact water quality, particularly for nitrogen and then potentially also for phosphorus. But then, are those costs per pound of N&P load reduction attractive enough to justify public or market-based investments? So storage is expensive. And so if we're going to actually build these systems, we need a way to help pay for that storage. And so again, whether that's public or market-based investments that can help make that happen. And then how do we actually quantify and verify those? And again, that's a research question that still needs to answer. And then from work that ISG and others have been doing up in Minnesota, looking at storage and drainage systems, we know that adding storage benefits shared drainage infrastructure. But then if we build in irrigation, then how do we create arrangements to do that within that shared drainage infrastructure? So relatively simple if it's all one landowner where we've got the storage and the irrigation. But if you start doing it with multiple landowners, then you're going to have to create the right kind of situations to make that work. And then again, are there other benefits that can help support financing? And so, a number of different benefits that potentially are there with these systems. If you're looking for more information on what we've done in Iowa and the results we've got, a couple of publications I'll point you to available on the Iowa Soybeans website. The one on the left is just a kind of a 2-page infographic version. The one on the right is a longer 8-page one with some more details. So with that, I'll wrap up my portion then. I think we've seen that drainage water recycling increases yield and reduces downstream nutrient loss. Those benefits are expected to continue and increase with trends in precipitation. But then, there's still room for more research to quantify these benefits and support financing adoption of this practice. So with that, I will stop sharing and we can move on.
Great. Thank you so much, Chris.
Yep.
As a reminder, you can put your questions for Chris in the Q&A panel. Next up, we have Kelly Nelson. Kelly is agronomy professor with the University of Missouri. So we're excited to have him here. He's also working on drainage water recycling, but looking more specifically at corn and production. So I'll turn it over to him.
Thanks, Annie. Thanks, Chris, for the overview and everything. I got the request out to talk on this, and it was like I guess I have a little bias on who's the heavy lifter, so we'll talk about that a little bit up front, but we'll address that question later at the very end. So just what I want to do today is kind of go over the kind of a layout, a little bit of an overview of Missouri. We'll move into a synthesis of drainage water recycling systems throughout the Midwest, and then we'll come back to a kind of an on-farm application of drainage water recycling. So just a little background on Missouri. In the northern part of the state, we have about 70% of the corn production, 60% of the soybean production. A lot of this ground is highly erodible land as well. So it's much different from the Boot Heel, which is delta ground. So management is completely different from that part of the state. We have a lot of in-field practices that are very important for managing nutrient loss, enhancing conservation tillage, cover crops. We do a lot of infrastructure when it comes to building terraces in the state as well. So that leads us opportunities for edge of field technology, and ultimately, drainage water recycling, I think, is a very important component, especially since I always joke that we're one day away from a flood and about 7 days away from a drought. So I think this builds a lot of resilience into our cropping systems. Again, that water cycle, when we think of phosphorus and nitrogen cycles, these run hand in hand. And usually when I'm talking to farmers and stuff on production issues, the number one issue is weather, followed by nitrogen availability, and what affects nitrogen goes hand in hand with weather issues. So just as a reminder, we are on a lot of poorly drained soils, so denitrification's a big issue. Within 2 to 3 days of those soils being saturated, we can lose a significant amount of nitrogen due to denitrification loss. If we like no-till, we can have volatility loss if we don't get a rainfall within a certain period of time. Once we improve drainage, internal drainage, leaching loss becomes an issue. If we like cover crops, immobilization can be an issue. But ultimately, we want to grow a corn crop, and corn uptake is our whole goal, and minimizing loss is the goal of every producer out there. So we're going to go back a little bit in time. We started drainage water recycling research in about 2000. So we're going to go into the bottom right-hand corner of this Google Maps picture to the Ross Jones farm, and then we'll take a trip over to the right to the Grace farm. Okay. So drainage water recycling. We started this work in 2000. We got everything installed in 2001. We had an existing reservoir, which was part of a cattle watering system. It was about a 6-acre reservoir. Each of the fingers, we had a rotational grazing system that we watered cattle out of. But we were looking at more resilient cropping systems, and so we didn't have a lot of subsurface drainage installed in the state. And so we were looking not only at drainage, but also the sub-irrigation portion that Chris was talking about earlier. So, and we were also interested in drain tile spacings, not only for drainage, but also sub-irrigation. So that water is removed, it's captured in that reservoir, and then we're pumping that water back up for irrigation purposes at this site. And just for reference, we're about an hour from the Iowa and Illinois border. Okay. So over 15 years of work, I'm going to take you down to the bottom part of this table. You're looking at average yield increases with free drainage, okay, in that first column or that second column over. So we're looking at about a 26 bushel yield increase with free drainage at a 20-foot spacing compared to no drainage, and then a 50 bushel increase with drainage, water recycling, or sub-irrigation systems. Okay, that's equal to about a 20% increase with free drainage, about a 40% increase with drainage water recycling. Now that transfers into about $100 per acre per year gross margin increase with free drainage, about $175 per acre per year gross margin increase with our drainage water recycling system. So the we we had a transforming drainage group. It started a large project as part of the Conservation Drainage Network. As part of that project, we were synthesizing sub-irrigation systems or drainage water recycling systems throughout the Midwest. And the bars represent the yield increases at that point in time to drainage water, the yield increase of drainage water recycling compared to just free drainage. Okay. And if we look at that in a little more detail, along the vertical axis, you're looking at drainage water recycling yields. Along the horizontal axis, free drainage yields. And anything that's on the left side of that diagonal line shows a yield benefit of drainage water recycling compared to free drainage. And in general, we're seeing a yield increase or a similar yield between those systems. If you move on over to the right, we can see two big things that glare out at us. First off, that average yield, represented by the dot, is increased about 20 bushel per acre with our drainage water recycling system compared to free drainage. The other thing is that variability in yield is decreased about 25% when we're comparing the drainage water recycling to free drainage. We identified the optimal timing for supplemental irrigation. It was in that V9 to R2 stage of development. And as Chris mentioned, we don't need irrigation every year. We do note that in these dry years, we see a very significant increase in yield. In general, as about 43 bushel per acre when compared drainage water recycling to free drainage, and that was about 25% of the time. When we get into normal years, it's about 50% of the time, and wet years, we don't see that yield benefit. All right, I'm going to take a little trip to our Grace Greenlee Farm. Okay, in 2014, we acquired another farm at that point in time, and administrators were like, "What are you going to do with it?" And we looked at it. I looked at it as an opportunity to basically feature uh, conservation practices throughout that farm, kind of on a landscape scale. I initially thought, well, let's put a dam down here in the bottom right-hand corner. Obviously, everybody said, you can't do that. You've got to get the Corps of Engineers involved, Kelly. And so we opted to build that dam up a little farther uh, uh, over to the left of where that tree line is located. So we had a lot of partners involved in the project to establish what we're calling a conservation showcase. Okay. And basically, that integrated a lot of practices together. And at the heart of that is our drainage water recycling reservoir. Okay. So that reservoir turns out to be about 13 acres in size. It's capturing about 145 acres of surface as well as subsurface drainage water from our site that was installed uh, at. And then in 2022, uh, we were installing some innovative outlets to look at. We were uh, draining that water into the reservoir as well. You can see I've got a little bit of a algae bloom on that reservoir, which isn't a big deal. It's on site, it's on farm, and we can utilize that water uh, for irrigation purposes. All right. One of the components that we did at this site was we installed what I call a wet well. And so this unit has a pipe that goes out into that reservoir. We've got an electric pump. We can also monitor the height of the lake in at this location, so we can evaluate the amount of water that is removed from that reservoir, and evaluate water that is used for irrigation purposes as well. So one of the components of that system was monitoring what went in versus what was leaving. We're in the early stages of that. Along everything in blue is what we're monitoring. Some of the ones over to the right don't go into that structure, but we have a lot of surface water that we're capturing because of our diversified landscape. Okay. So obviously the neighbors contributing a significant amount of water. This is a conventional tillage system, and we have a lot of stacked practices. This is an established waterway that's contributing to that reservoir as well, in addition to our subsurface drainage system. Okay. And then obviously loading is going to we're evaluating output versus inputs. Again, this trying to get an understanding of all of those practices, which one's contributing, are the the least losses, and which one's contributing the most to that reservoir, as well as what's the fate in that reservoir as well. So one of the components, we actually designed it so we could take water from that reservoir and pump it through. There was an area of the field that we couldn't capture that water from, and so we can actually put that water through a saturated buffer. It's a controlled drainage system and a bioreactor. And so this stack practice. We see over 5 years that stacking controlled drainage, bioreactor, saturated buffer works very effectively at reducing nitrate loss. However, when we look at precipitation events, Okay, as we move from a half inch of precipitation over those 5 years to a half inch to an inch of precipitation, down here to an inch to or an inch and a half to 2 inches, and then when we exceed 2 inches of precipitation, the efficacy of those practices did decrease, and so really capturing that water and drainage water recycling might be a way of enhancing those stack practices. So when it comes to the heavy lifting, the reason the reason we're doing what we do is for crop production. We want to make sure that we're implementing the best management practices when it comes to conservation. We want to manage erosion, nutrient loss, gas loss mechanisms, and also enhance our soil water resources. So at the end of the day, I think drainage water recycling is a very important component, especially when it comes to the resilience of our systems. But integrating these landscape-based technologies with stack conservation practice, I think, is going to be the key, especially when we get into very diversified landscapes that we're experiencing. So with that, we'll stop sharing and turn it over to Asan.
Interesting. Thank you so much for sharing. All right. Next, we're going to change direction a little bit. We've heard some research from Chris and Kelly on drainage water recycling. Next up, we're going to hear from Asan Ganj, who's with a associate professor and extension specialist with Michigan State University, but he's also a member of the Conservation Drainage Network. In fact, I believe all three are members, but he's going to talk a little bit about the network and about the resources available there if you are interested in learning more about conservation drainage more broadly. Turn it over to you, Asan.
Yes, hi everyone. Thank you for the introduction. So I'm going to be talking about the Conservation Drainage Network uh, um, as you heard, all of the presenters today are part of this organization as well, the Conservation Drainage Network. I have a screenshot of the website and a photo of the website. I'm going to move into the structure of this organization. So this organization had a former previous structure before, and in the late 2019, the organizing committee came together and restructured this. As you can see, this screen shows the new structure of the Conservation Drainage Network, and the inaugural meeting was in the year 2020 back then. So you can see we have a diverse group of participants that work together to accomplish great things. So in the center, you see the Conservation Drainage Network. You got state and local agencies, national, international agencies, private individuals and groups, NGOs, industry, which would be the arm of the ADMC, Agriculture Drainage Management Coalition. That's a big part of this group as well. And then when it comes to the research and education group here, you see there's two subgroups of that. There's the Transforming Drainage, and there's a NSERA 217, which is the multi-state research group that come together to do research in the area of drainage. So this is a new structure. And let me explain a little bit about the NSERA 217, which is a part of this Conservation Drainage Network. So like I said, this is a multi-state group that is organized by land-grant universities, and it's funded by USDA NIFA. So the drainage industry and agencies, they present the research questions that go to the NSERA 217, the researchers and the extension personnel within that group, and the research solutions go back and they get implemented, and industry and agencies use those in their work and also policy making. So this is kind of the relationship between that arm of the NSERA, the research, and also the drainage industry that works together under that Conservation Drainage Network. So as I mentioned some of the members here. Now I'm going to mention a little bit about the goals of this. So really the goal, as you heard in the previous talks, is meeting the crop production demand. That's number one. And also the second one is reducing adverse environmental impacts of drainage. And that means reducing the nutrient loss, the nitrogen and the phosphorus. And that diagram on the right shows the relationship between those. And you see increased yield and improved water quality and improved drainage system. These are all linked because improvement in drainage system through conservation drainage is going to lead to increased yield, as you saw in the drainage water recycling, and that's going to lead to the improved of water quality, reduced nutrient loss. So really the primary responsibility of the group, this conservation drainage network, is to organize an annual meeting, which is coming up very shortly. And some of the outputs of the group, so this is the screenshot of the website. There's annual meetings, as I mentioned, that's the primary output. There's field days that come with those annual meetings. And I would show you, I would go to the website. So the website is conservationdrainagenetwork.net, conservationdrainage.net. So this is the website. The meeting that I mentioned is coming up on April 1st to 3rd. And this is going to bring together all of those members that I showed you in the graph, all of those industry agencies and all of the other members. So as I mentioned, the goal was to increase crop production, reduce environmental impact of drainage. And I'm going to show you what's coming up. The meeting that's coming up very shortly in April. And you can see what sessions that are going to be hosted. We have excellent sessions coming up as part of the Conservation Drainage Network. The organizing committee is the group that really steers this organization, the Conservation Drainage Networks, by the leadership Yaba Kjøsgaard and other members of the leadership team here that I can see on the screen. One thing that I want to show you also is the media library here, where you can find educational material, like you see an educational video about videos of drainage water recycling. So this is a valuable resource here. You can open and review these resources here. There is a resource library as well. So in the resource library, you can get information about extension bulletins, fact sheets, as you can see in here, water quality database. So everything, so this is the one-stop shop for all drainage. So you can find information here about that. Another website I wanted to just very briefly point out is the Transforming Drainage group. That was the other member related to the research arm of this group, which is this group. And so you can see there are 3 conservation drainage practices here: controlled drainage, saturated buffers, and drainage water recycling, which was the topic of today's talk. And if you click here, you can read more information about that drainage water recycling. There are fantastic tools on this website. Wide range of conservation drainage. You can see the sub-irrigation one that Kelly mentioned, drainage water recycling, controlled drainage suitability, drainage rate, drainage spacing tool, and many other products that you can find on this website about conservation drainage practices. Thank you so much.
All right, wonderful. Thank you. All right, it looks like we do have some questions coming in, so we'll go ahead and start to address that. All right, looks like the first question I see is for Chris. Chris, do any of the drainage project fields shown in your presentation use or have the need for Hickenbottom tubes? You mentioned depressions on the Dayton project.
I guess of the sites we've been using so far, we don't have any that have surface intakes. on the site itself. Now, in that one at Lake City, I know that there are some surface intakes up in the drainage district, and so some of those would be contributing some surface flow through those surface intakes. The Dayton one, it's a relatively small drainage area. I'm not aware. I know there aren't any on the field itself, but I'm not aware of any in kind of that upstream area on that site. And then, yeah, the other one, there's enough topography that they really don't have an issue with surface water on that one either.
Gotcha. Thank you. This question is from Bob, most likely to either Kelly or Chris. What would be a representative water storage volume, and how much of this volume would be used during a typical irrigation cycle for corn for center pivot with 130-acre wetted area? You know that off the top of your head? I'd be impressed, but I'm curious. Maybe they're looking for a ballpark here.
Sure. So I'll take a stab at it, and Kelly, you can add your thoughts if you have some. So, a little bit of the work that one of our earlier grad students did some modeling to look at what what we might need for irrigation supply and storage, and then modeled over a number of years to get an idea of what the applications might range from. So with that, then we looked at some different levels of storage, and starting at kind of 4 inches of storage, with the thought that if you're putting on less than a couple inches, it's probably not worth the investment. So you need a little bit of extra to make sure that you have that couple of inches. And so we started with 4 inches. We looked at 6 inches, and then we looked at an unlimited water supply. And so what we saw was you get a pretty good yield increase with just 4 inches of storage. You get a little more with 6 inches of storage, but beyond 6 inches, there really was no additional benefit. So it seems like kind of that sweet spot is about 4 to 6 inches of storage for each acre that you're irrigating. So, if you're irrigating 130 acres, you multiply 4 inches or 6 inches times that, and you get that in acre inches then. So that's, again, so far seems to be kind of the sweet spot, at least where we're at in Iowa. Then when we look at what's actually getting applied with that 4-inch storage, it ended up being an average of about a little under 3 inches per year on average. So again, some years it's more, some years it's less. And then for 6 inches is right at about 4 inches on average is what the model said would be applied. So that's, again, kind of what we're looking at right now.
Great. I think that's really helpful information. Kelly, anything to add to that?
I'd say that, we're not trying to supply the whole season, and so it's very important to, we're not, and that sizing, yeah, Chris is spot on with that. So again, we're not trying to solve a drought issue. We know that if we have some strategic irrigation events throughout the year, that can have a very significant increase in yield, especially in drought conditions.
Yeah, this question is kind of similar. She's asking about reservoir size would be needed. I think you've answered that, Chris. And she's curious, this is Teresa, about the ROI. Like, seems like a very large upfront investment. What happens during the dry years? So just speak a little bit more about that, because you said you're not, in terms of drought. Can you speak a little bit more about what happens during those dry years?
Well, so I guess in general, as far as ROI, that's some of what myself and others are working on right now. And so working with ISG engineers and Environmental Defense Fund to look at kind of the economics of these systems. And so, some of our initial work has suggested that the irrigation investment is, right now, it more or less pays for itself, but just barely. Again, as we look into the future, that equation is going to continue to change. And so it's going to become more and more cost effective as we move forward. So, we're still trying to figure out, again, kind of the best sites where we're more guaranteed that we're going to get that ROI on the irrigation investment, and other areas where we may not at this point yet. So that's, one of those still questions we're working on. Then storage, again, is expensive. And so that's, again, if the farmer has to make the investment in the storage too, that's probably going to knock out most systems. And so that's where we're looking at, okay, can we pair the private benefits for the irrigation with the public benefits to water quality from the storage and the recycling. And then again, whether that's public investment through cost share programs or whether it's market-based incentives for, paying for water quality outcomes. Something like that is probably it's going to take something like that to pay for the storage part of that for the water quality side. So again, that's trying to create these win-wins where we can pair the benefits and pair the financing to make this happen.
Great, thanks. Might be a both and in that
Yeah.
situation.
Yeah.
Are there any, and this might be for all three of you, are there any water laws you have to navigate before implementing these water recycling projects? Danielle is curious. I see
Yeah.
smiles automatically.
So, I guess early days in Iowa, and so far it's been relatively easy. The one where it is flowing through the waterway, that one he did have to get an irrigation permit. It was a watershed where that's not really an issue, and so we applied for it and got it without any real question. The other site where he's pumping out of the stream to supplement his drainage supply, that one also required an irrigation permit. They have been shut off in a couple of years where the stream flow was low enough that they shut them down and weren't able to pump water for irrigation. The one where it's being pulled out of an underground drainage main, at this point they've said that they're not considering that state waters yet, and so they actually didn't need an irrigation permit. So I think we all recognize that as we move forward, if this gets done more, then you're going to start to create some potential water conflicts. And so we are working with an attorney as we look at some of this to start thinking about, okay, how do we create, again, kind of the right conditions so that we're not causing harm to downstream folks, or if someone puts a system downstream, it's not upstream, it's not harming someone downstream. And so some of those questions are yet to be answered, but I know at least in some other states, so North Dakota and Minnesota, there's a few sites that have been done up there. They've been much more stringent on water law, and so they did have to jump through quite a bit more hoops to be able to put those systems in. So there's going to be some state to state variation in some of this too. And then not really water law related, but Corps of Engineers is a big one right now. And so anything, in waterways or that touches waters of the United States, that can be pretty tricky right now working with Corps of Engineers, depending on which district you're in.
Right, and Kelly, you had mentioned some of that yourself, correct? Anything to
Yeah,
add?
and that's something that, as Chris mentioned, state specific issues that, we were targeting an area that was going to be too big of a drainage area. In fact, the folks that were designing it, we were going to have to get some approvals, but that's why we backed that out to another location. So, yeah.
Here's an interesting one. Kevin, it looks like he's actually in Southeast Arkansas. He's curious if there is any growing interest in floating solar panels for these. I'd put that to all three of you. I don't know if any of you have come across that.
Yeah, that was one one of our partners on the Transforming Drainage project, and she had run across this, and so I think we all kind of thought, well, that's kind of forward looking, but at least with something interesting that maybe it would happen in the future. Well, I was talking about it at a field day, and a farmer just glommed onto that and was really interested, and so we've actually got a site that is just going out for bid. And he's actually looking at that as an option. So turns out there is at least one company in Indiana where their market is these farm storage ponds, and they do floating solar panels. And so I think that's an option. And so he's looking at that. And part of that is because it's one where, again, he's going to be pumping out of an underground drainage main, but to try and get as much water quality benefit, because he is getting some state funding with that, they want him to pump as much and let it flow through that system as they can, so less water is bypassing. So that's kind of the agreement then, is they'll use solar panel for that pumping, so he's not paying the electrical cost to be able to pump beyond what he needs for just irrigation. And so that he can get that additional water quality benefit. But then, he can potentially put excess power back into the grid and get some cost savings that way too. So not as far-fetched as maybe we first thought, but so maybe a site that's coming online. And again, I know of other sites elsewhere in the U.S. I know they're floating solar panels and irrigation canals in California, and then some other places where similar types of things are happening too.
Oh, great. Yeah, that's wonderful to know that it is happening. Parker's curious, do you have any recommendations or resources specific to urban farms interested in improving drainage? Maybe even in those smaller spaces. Have any of y'all worked with that within your work, or know of folks within the larger conservation drainage network that have worked in urban spaces?
That's a good question. I
Yeah.
know it's not something I've dealt with. I'm sure there's some folks out there. I'm off the top of my head, I'm not sure who they are. Maybe you guys have some ideas.
Well, it might be a good opportunity to call upon that conservation drainage network then, 'cause
Yeah.
it's larger than
Yeah.
this group of us four here that might have a bigger pool to say, yes, I have, or, no. So maybe that's an opportunity. Parker,
Yeah.
I would suggest starting there. Dennis is curious, any estimate of the number of these installed around the Midwest? That's an interesting question. Does anyone have a good handle on that? I wonder.
That is, yeah. There's there's less than 10 in Iowa. I'd say 5 to 7 in Iowa right
Okay.
now, with a couple more coming on board. I think you've got maybe 5 sites in Missouri, Kelly, something like that.
Yeah, we've got 5 sites, but we've got, I mean, that's a tough number to because it's a private. Uh, um, I could probably get a hold of some contractors and see how many they've installed, but again, you've got the storage, you've got to kind of have everything come together at the right time for that to work. Um, but yeah, that's a great question.
And then I think there's just a few here and there, and some others. Like I said, there's a couple in Minnesota, a couple in North Dakota. I know there have been some plans for some in South Dakota. I'm not sure if they've been built or not. There's a few in Ohio, at least one in Michigan, potentially some others. And like, I know there are some private ones that I've seen or heard about, but I don't have a firm number on what those are.
Great. I think we have time maybe for one more question. I'm going to go with a question from Kevin here. Different Kevin. Is there any filtering of the pond water needed in order to pump it through the irrigation system? May depend on whether you're applying overhead versus drip.
So yeah, we did drip irrigation sites for several years, and yes, it depends on where you're pulling it out of that pond as well. And yeah, you would need a filtration device for irrigating through a drip irrigation. For overhead irrigation, it's less of an issue. For our sub irrigation systems that are going back through the tile lines, we do not have any filtration on those systems.
Okay, great. But yeah, very pertinent question. I'm also seeing a note here for the individual who asked about urban that Irma in the chat is noting that she knows of a small farm in Detroit that has an underground cistern. The pump is solar powered. So again, it doesn't, just because that we might not be aware of those options doesn't mean that other folks within this kind of drainage community aren't familiar with it. So be sure to reach out. With that, I'm going to share my screen and share the emails for our presenters today. So Chris, Kelly, Assad, thank you so much for joining us and lending your time and talent to share some of your work. I hope everyone was able to access this. It will be, if you were wanting to share this presentation afterwards, it will be available on our website, northcentralwater.org. Excuse me, not Soil Nexus, just the northcentralwater.org. Afterwards, as well as the presentation slides. And if you had a question specific to one of the presenters, excuse me, their emails are up on the screen there. I encourage you to join us for our next The Current webinar. It's going to be coming up on March 12th, and we're going to be focusing on state nutrient reduction strategies. Thank you all so much for being here today, and I hope you have a great rest of your day.